You read the first line of a physics problem and your brain freezes. You're not at the final answer yet. You're not deep in the algebra yet. You're not even halfway through the setup. The problem is that you don't know what to do first. And if that keeps happening to you, this video is for you. I'm the physics sensei, PhD in physics, black belt in karate, and 30 years helping college students like you to stop freezing at the start and learn how to begin with confidence. In this video, I want to show you why that freeze happens so fast and what simple step you need to use instead. Because most of the time, the problem is not that you're bad at physics. The problem is that you're starting in the wrong place. But first, you need to understand why this happens so you can correct that easily. So let me show you what exactly happens. A student reads the problem. They see a number, they see a mass, velocity, force, acceleration, whatever the topic happens to be. And the moment they see those pieces, their mind starts searching for a formula immediately. They think, which equation do I use? They want to move right away because standing still feels uncomfortable. So they try to do something fast because in their minds, not doing anything, it's a sign of failing. So they start writing symbols, they start plugging numbers, they start guessing what chapter this looks like. And within a few seconds, the whole thing feels messy. And that is when you freeze. It doesn't look dramatic, it doesn't look like a panic attack. Sometimes it's just confusion, sometimes it's hesitation, and sometimes it's that feeling that you should know what to do, but nothing feels clear enough to begin. And then the pressure starts building because now you're looking at the problem, the clock is moving, and your brain is already telling you that you are behind. So here's the hidden mistake. Most students try to calculate before they understand the physical situation because they need to feel that they are doing something to solve the problem. They move to equations too early. They are trying to solve before they even organize what the problem is actually describing. And that is why they freeze, because the first move in physics is usually not a calculation. The first move is orientation. You have to understand what kind of physical situation is in front of you before the equation means anything useful. If you skip that step, the numbers don't help. The formulas don't help. The chapter title doesn't help. All of that just creates more noise. So the student thinks the problem is that they forgot the physics, or that they are weak at math, or that they are not smart enough for this class. But many times that is not the real issue. The real issue is much simpler. They started too fast. And the fix is also simple. You must slow down, especially at the beginning. Now the problem is how to do that. So let me show you that. A lot of students feel this urge immediately. Their mind starts pushing them to do math. They want movement. They want to grab a formula. They want to start doing something. So calculating something gives them the sense of I'm moving forward because standing still feels uncomfortable. That is normal, but it's also the challenge because in that moment, your mind is in rush mode, not in organized mode. And if you start solving from that state, the problem usually gets messier very fast. Think about driving. You do not get into your car and immediately jump into the highway at full speed. First, you get oriented, you catch where you're going, you pay attention to the road, the traffic, the directions that you're driving. Only then you go into the highway and then you move faster. So physics problems work the same way. If you rush straight into the math, it is like trying to drive fast before you are oriented. This is why things start feeling messy so quickly. So instead of letting your mind run straight to the math, try redirecting it into a more organized mode. Before you write an equation in any problem, you need to answer three simple questions. What is happening? What am I trying to find? What kind of physics situation is this? So you read the description of the problem and you answer these three questions. No math, no formulas, no numbers yet. That is the challenge. Those questions help you slow the rush and guide you to the next step. This becomes your system. You're still moving, but now you're moving with more control instead of just reacting. Physics often breaks before the math begins. This is one of the most important things to understand. If the setup is weak, the rest of the problem will feel unstable, even if you know the formulas. Because now you're doing math without direction, and math without direction is usually chaotic. So, what are you going to do instead of that? Before you touch a formula, you stop and identify the physical situation. And again, you ask, what is happening here? What am I trying to find? And what kind of physical situation is this? So you're not answering what equations should I use or what numbers should I use first. Those last questions don't help to start the problem the right way. And then you continue asking these. Is something speeding up or slowing down? Is something falling or sliding or hanging? Is something moving in a circle or staying in balance? Is this a force situation, an energy situation, a motion situation? You notice that instead of rushing into numbers, you're moving into a different mode. You don't need to solve the whole problem yet. You're just trying to recognize the kind of situation you're dealing with. That is the challenge, and that is also the fix to that freeze that you often feel. That one step changes everything because now instead of grabbing random formulas and hoping one of them works, you are creating direction. You are telling your brain, this is the kind of problem I'm working right now. And once that becomes clear, the next step becomes easier. This is what strong students often do without realizing it. They do not always move faster because they are smarter. Many times, they move faster because they organize earlier. They get clear earlier. They do not let the numbers rush them before the physics makes sense. So if you keep freezing on the first line, don't tell yourself that you need to study harder. And don't tell yourself that you need to memorize more formulas. Don't tell yourself that the answer is to move faster. Usually, the answer is the opposite. Slow down at the beginning so you can move with direction after that. Here's the key idea I want you to remember from this video. The problem is not that you're bad at physics. The problem is that you're trying to calculate before you understand the situation. That is why the freeze happens so early, and that is why the fix has to happen early too. So the next time you read a physics problem and feel that mental freeze, don't ask, what formula do I use? Instead, ask, what is happening here? And start there. That one change can help you stop repeating the same mistake over and over again. Now, after you try all these steps on your own and still keep having the same situation, I would suggest you to start training in the dojo. You can start with the free dojo and train these steps the right way. So that next time, instead of freezing, you will move forward with confidence. You can visit the dojo anytime and you can start training today. The link is in the description. Train the basics, build your foundation, and let consistency become your advantage. I'll see you there.